University of St. LaSalle College of Arts and Sciences Mathematics Department, and this is our video solution for our problem number 5 posted in our Facebook page with difficulty of 3 stars. We have this 3-star difficulty because this is our 5th problem posted online. Hopefully we'll do this to every 5th problem to give you a super difficult one. And yes, this one, no one has ever given a solution to this problem since they posted it like 5-6 days ago. So here's the problem. Well, suppose that a collection of terms a sub n, where n is greater than or equal to 1, is an arithmetic sequence of real numbers such that a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus until a sub 10 is equal to 20. And a sub 1 plus a sub 4 plus a sub 9 plus a sub 16 plus until a sub 100 is equal to 18. We need to compute a sub 1 plus a sub 8 plus a sub 27 plus a sub 64 plus until a sub 1000. So we need to get the value, the exact value of this sequence here, just like getting the value of 20 and 18 are given. So what's the value here? What is it equal to? So this is a 3-star problem again, so we'll have our solution as follows. So we'll have our givens here. So we'll try to first observe in our given arithmetic sequences. The first one, we can see that the nth terms here, 1, 2, 3, 4, are all set of counting numbers. 1, 2, 3, 4, we can imagine this is 5, 6, 7, 8, 9, and 10. Okay, so if we're going to add the first 10 counting numbers, the first terms, okay, which is the first 10 terms, that's equal to 20. Okay, so we have 10 terms in our first sequence. In our second sequence, as you can notice, these sequence are all terms with the perfect squares n. Okay, this is a sub 1, this is 2 squared, a sub 4, this is 3 squared, a sub 9, this is 4 squared, a sub 16, next here is a sub 25, a sub 36, and so on and so on and so on until a sub 100. Okay, so which is 10 squared. So we have here the sum is 18. So, well, it doesn't mean that we have a lot of terms in this ellipsis here. Only that we have 10 because they are all perfect squares. And 100 is the 10th perfect square. So therefore, we'll have 10 terms here, not really a lot. So which will lead us to compare with our third equation, the one that we want to get the value with, our third sequence. They are actually terms with which is composed of our perfect cubes, the nth perfect cubes. So we have a sub 1, that's 1 cube, a sub 8, that's 2 cube, a sub 27, that's 3 cube, a sub 64, that's 4 cube, and so on and so on and so on until 10 cube, which is 1000. So again, these sequence are only composed of 10 terms actually, not really a lot, but 10 terms since they're perfect cubes, and 1000 is the 10th perfect cube. Well, so how do we start? So we really can't get the value of the individual terms here. Okay, we'll get a sub 1, a sub 2, a sub 3, a sub 9, a sub 16. That will be a very tedious process to do and somehow quite impossible. So what we'll do will be as follows. So commonly, we'll let a sub 1 as the first term. So in this problem, we will go a step backward. We will let a sub 0 as the 0th term. Well, which is quite legit because a sub 1 is the first term, so if we say a sub 0, that will be the 0th term. And of course, d will be our common difference. Okay, d will be our common difference there. So in this way of representation, we can see that a sub 1 is equal to our 0th term plus the first common difference. Imagine our common difference to be 1. If our a sub 0 is 0, 0 plus 1 will lead us to our first term. A sub 2 will be 0 plus twice the 1, which is 2, and then so on. So meaning we could say that a sub n is equal to a sub 0, our 0th term, plus the nth term, the nth times we multiply the common difference, then add it to our 0th term, and that will give us our a sub n, our nth term. So in this way of representation, we can see that this will be follow. And then what we'll have in our arithmetic sequences above will be something like this. A sub 1 will be equal to a sub 0 plus d. A sub 2 will be equal to a sub 0 plus 2d. A sub 3 will be equal to a sub 0 plus 3d. A sub 4 is equal to a sub 0 plus 4d, and so on. This will be our first sequence then, equals 20. Okay, in our second sequence, we'll do the similar thing as follows. A sub 4 will be a sub 0 plus 4d, a sub 9 will be a sub 0 plus 9d, and so on. Those will be our second sequence. Okay, and then our sequence that we want to get the value with will be something like this, which is equal to question mark. That's what we want to get, actually. So from here, we'll figure something out. Okay, so let's move them there above. So what we can do is that, well, we're composed of a sub zeros now and d's. So thinking about a sub zeros and d's, we can combine them, actually. So we can see the values of our coefficients d, the common difference, to be something special. We can combine them. Observe in our first equation, okay, the sequence of d's are 1, 2, 3, 4, 5 until 10. So it's like adding all the counting numbers from 1 to 10. Okay, so if we're going to add all those numbers, 1 plus 2 plus 3 plus 4 plus 5 plus 6 up until 10, we'll get the sum of, what's that sum? That's a popular problem that was answered by Gauss, the young Gauss. That's equal to 55. Of course, we're going to add the a sub zeros. 1 plus 1 plus 1, that's 10 a sub 0 plus 55d equals 20, which shortens our sequence into an equation. Okay, likewise, in our second equation, we're going to add the d's also, the coefficients of the d's. d, 1d plus 4d plus 9d plus 16d plus 25d, and then until 100d. So if we're going to add all the perfect squares from the first perfect square, 1, up until the 10th perfect square, 100, that will give us the sum of 385. So you can add them manually, okay? And then the sum is 385. And of course, add the a's also, a sub zeros rather, 10 equals 18. So that will simplify our sequence into a very short equation. Likewise, we can do that in our third equation, the one that we want to compute. We're going to add the perfect cubes from the first perfect cube until the 10th perfect cube, 1000. 1 plus 8 plus 27 plus 64 plus until 1000. That will give us a sum of 3025d. Okay, and of course add the a sub zeros also, which is equal to question mark. So what we have here, instead of sequences, what we'll have is a system of equations. One may call it simultaneous equations. So which we can do some with some elimination or substitution with. Let's put it there aside. So what I would like to do particularly, okay, is to pair up the first and the second equation. Here you go. Okay, and then subtract the second from the first by using some elimination techniques. So if we're going to do that, the 10 a sub 0 will be cancelled up. If we're going to do this here, this will be negative 330d, and then 20 minus 18 is going to be positive 2. So we'll have that. This will be another equation that will be added to our list. Let's put it there. Okay, and then what I would like to do in this new equation is I just want to multiply it by negative 10, or negative 9 rather, negative 9. So I'll multiply this negative 330d equals 2, multiply it by negative 9, which will give us a new equation, which is this. 2970d equals negative 18. And then I would like to add this new equation of ours to our first equation. Okay, so if we're going to add it, we're going to have a 10 a sub 0 here. Then we're going to add the coefficients of d and then add these two numbers. And what we'll have is 10 a sub 0 plus 3025d equals 2. So wait, if you can notice and you'll observe, this 10 a sub 0 plus 3025d is our third equation, the one that we are finding the value with. But here, it has a value on the right hand side. Okay, so meaning this is the answer already. This is the answer. The answer is positive 2 because 10 a sub 0 plus 3025d is exactly the same with the ones that we want to compute with. So with this answer, this is the one we're looking for, positive 2. So this will be our answer for our problem number 5, a sub 1 plus a sub 8 plus a sub 27 plus a sub 64 plus a sub 1000 is equal to 2. Okay, so that's our answer for this problem number 5. As you can see, it's not a, 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 it's it's not a common way to answer a problem, not a really a routine way to answer a problem. So you see we change the sequences into a set of system simultaneous equations, and then add some did some things with that simultaneous equations, and then finally come up with this equation which is exactly the same with our third equation, and then with the value now. So this value is what we're looking for, which is equal to 2. Okay, hopefully you're enlightened now by our answer here. So if you want more problems, math problems, kindly like and follow our Facebook page. It's written here. I'll put it in the descriptions below also. So we'll be posting the 6th problem soon. So stay tuned and don't forget to like our YouTube channel. Thank you.